All right, folks, we'll go ahead and get started. Thank you for taking the time to come to this talk on the last day and right after lunch. So hopefully we have an entertaining talk to keep you going for another couple of hours before you're done with the conference. So the talk that we have today is basically talking about big data workloads with Azure Blob Storage. And what we'll cover today is basically give you a very brief introduction to Azure Storage and Azure Blob Storage. Just sort of a refresher, we assume many of you know about Azure Storage and Azure Blob Storage, but for those of you who are new to this, we'll give you a very quick rundown. But the bulk of the talk is really talking about big data use cases and how object storage on Azure fits into those use cases. We'll talk about the different big data services that Azure offers and how they integrate with Blob Storage. Along the way, we'll also cover a bunch of the key capabilities of Blob Storage and how they enhance your big data scenarios and your big data uses. We'll also intersperse our 2017 roadmap with that. We'll, of course, be showing you stuff that you can go try right away from the portal, our demos and things like that, and the services that we'll show. But we'll also show you sort of a forward-looking view of what we're shipping in the next few months, primarily what's shipping in the rest of this year. So let's get started. So when you think about Azure Storage and what services we offer at a broad level, they fall into two buckets, the IaaS services and the PaaS services. On the IaaS side, we provide the disk storage for your IaaS VMs on Azure. So if you're running an Azure VM or running an Azure VM scale set, the persistent disk, the OS disk, as well as the data disk that you have are running on top of Azure Storage. And they may be magnetic disk-based disks, or which are called standard disks, or they may be SSD-based, and they're called premium disks. Both of those disk services run on top of the Azure Storage stack. The other service is our Azure File Service, which is essentially shared storage. It's a managed SMB as a service. So rather than standing up your file server and having that be a single point of failure, you can rely on our managed SMB service to provide shared SMB via a normal map drive or a mounted device on a Linux VM across all your VMs that require that. On the PaaS side of the house, where you're writing code against our services, we have three services: blobs, tables, and queues. Tables are our high-scale NoSQL key value store. As part of the Cosmos DB announcement, you'll note that there's now a table API at Cosmos DB. So you can use this key value store across those two services. You also have queues, which are a good way of doing intra-service and inter-service communication or any kind of asynchronous workflows when you're building them in your code. This is a very simple, inexpensive way of building those, building that service coordination. But the big item here, and the thing that we'll focus the rest of our talk on, is blobs. Blobs are our object storage platform. We'll talk a lot more about this in the rest of this talk. So I won't really refer to any of the other services anymore. Happy to answer questions at the end of this talk if you had questions about any of those. One reason we kind of talk about these as one continuum of services is all of these services, from our perspective at the core architectural layer, are built on top of a single unified distributed storage system. And what that means for you is, one, in terms of the core functionality that you depend on from a storage platform, whether it's consistency when you write data in, whether it's durability of your data, availability of your data, load balancing, and encryption at rest, and the others, all of the services benefit from this when we add that to our core storage platform. So that's something that's very unique about our offering, our cloud offerings, is that these are all built on top of that unified stack. Then when you look at blob storage, let's start talking through, what is it at a very high level, and then, quickly transition into what we can do with it for big data. So basically, as I was saying, it's sort of our object storage platform, right? It helps you to store and serve unstructured data of any kind. So whether you're looking at canonical workloads like just storing your app data or your web data or your mobile app data and you're trying to serve up data to customers, either data that the same data, static data is served, or you're storing per user data at very high scale, blob storage can serve those needs for you, right? Any kind of objects that you need to store, we can do that. We certainly do a lot of work in terms of backups and archive in the traditional storage world. If you look at enterprises and their backups and archives, there are a lot of partners and a partner ecosystem that ends up backing up stuff to Azure Storage or Azure Blob Storage. And then, of course, there's the new emerging workloads, big data, and basically where your data starts in the cloud and stays in the cloud. And this is sort of the place where between app and web scale data and big data is where object storage really comes into its own. And we'll spend more time on that third scenario, but know that the other two work really well as well. So before we get into kind of what does blob storage do, it's useful to talk about the fact that we actually have 3 different kinds of blobs, right? And this trips up people who are looking at our platform for the first time and are saying, well, which one should I actually use? Because most of the other cloud providers have basically one kind of object and one kind of object, right? And we have 3. The canonical one that you will use and that you'll most commonly see and most commonly fits your needs are what we call block blobs, right? And this is a blob that you can just put with a single put blob call. So it's an object, you just put it and we take it. Or you can, for larger objects, you can chunk the blob up into blocks, hence the name block blobs, arbitrarily sized blocks, upload them in parallel, and do kind of easy resume and all of that, as well as support good parallel download semantics and things like that. So this is what 95% of the time I'd say you'd be using block blobs. But there are 2 specialized kinds of blobs that we added based on our customer feedback over the years. The first one is append blobs. They look very similar to block blobs, except what they allow you to do is append to the end of the object without needing to lock the object. So if you think about scenarios like log data where you have many different writers coming in and writing to the same object, append blobs allow you to do it without any kind of lock semantics or consistency management. You can just fire off append blobs, and you'll know that regardless of the number of writers you have, they're all getting to get appended to the same blob. Otherwise, they look and feel very similar to block blobs. In terms of reading it later, they're pretty much exactly the same. So that's a good use case for sort of logging, some big data map reduce type jobs where you kind of aggregate stuff into an append blob rather than a block blob. The third kind of blobs are what we call page blobs, and these are very unique. They're basically giving you the ability to do random read and write I/O over an object. So normally when we think of objects, they're pretty much sequential I/O, right? You can go get offsets and whatnot, but they're primarily built for sequential I/O. We have an offering of blobs that are built for random I/O. So you can allocate a large sparse file, a large sparse object, and go in and write and read any 512 byte aligned chunk of that object. In fact, there's a different API called put page, because you can put pages of data in there. The reason we built this ages ago was because this is the underlying architecture for our disks platform. This is how our disks actually write to our storage system. So once we built that, we said, why don't we put a REST API on top of it and expose it to customers who need that scenario. Now, it's typically not used by your normal app dev workload. You probably will never use page blobs, but it's very useful for things like backup vendors and the like. When they plug into our system, they can do much smaller block sizes and in read and writes and efficiently. So these are the 3 kinds of blobs. Basic takeaway is block blobs are what you're looking for most of the time. And let's look at some of the capabilities that we have across the board with our blob storage system. So first of all, we talked about a little bit about consistency. All of our blob types are strongly consistent. What that means is you will have a guaranteed read after write consistency once you get a 200 OK from our service, right? We make 3 copies across 3 machines on 3 different racks before we ACK your write. And we do a lot of optimization under the covers to make sure that ACK and the 3 copies are super fast, even though we are waiting until we get that strongly consistent write. We also have multiple redundancy types across data, multiple copies in a single data center to multiple copies in other data centers. So you're protected against, you have a business continuity disaster recovery story, as well as having protection against force majeure events and the like. We have tiered storage. So we have a notion of a hot tier and a cool tier. So you can store your more frequently accessed app data in a hot tier and pay less for transactions, or store your bulk data in a cool tier. It's still active. It's online storage. Get it in milliseconds, but you pay a lot less for that data that you don't expect to access very often. We have broad platform and language support, and we'll talk a little bit more about this as well. Some other technical considerations, and I'm going to go through these fairly fast. There is a talk that we did at last year's build that really double clicks into each of these technical considerations. If this is something that's new or unfamiliar to you, we'll put up a pointer to that talk so you can go look at that. But there are some interesting technical differentiators that it's worth looking at when you're designing on top of blob storage and thinking about what you want to build there. The first and most interesting difference from other object storage, cloud object storage systems is we actually have a single top-level directory structure called a container. So we have our storage accounts. Storage accounts are like buckets. It's stuff that, a place to put your data. But underneath an account, you can have as many containers as you want. Containers allow you to do things, isolate things within a storage account. So, and you can operate atomically on them. So let's say you have 1 million blobs under a single container, and that container is now expired for whatever reason. You don't have to go delete all 1 million objects. You can just delete the container. Or let's say you have all of a single user's data, and you want to collect all of that under a container for that user. You can give that user in your application delegated authorization to that container and say, hey, you can read and write to this container, but you can't break out of that container boundary and go talk to somebody else. Now, of course, we picked the term containers 10 years ago, and it gets confused nowadays with compute containers, but they are containers in a storage sense. We also support parallel multi-part uploads. We talked a little bit about that. Those blocks allow you to upload. You can arbitrarily slice your large objects especially and upload them in parallel, do out-of-order uploads. And then you commit or materialize that blob with what we call a put block list call. We do support range get, so if you're trying to say, here's my very large video file and I'm streaming it out, I'm fetching specific segments, you can of course say, start at this offset into the object and get me this number of bytes, and you can do that in parallel across many parts of that file, and that works just fine. Another very, very unique thing about our platform is our objects are actually mutable. Right? Again, canonically, you think about objects as, hey, the only way I can replace an object is put a new object on top of it. And if it's a large object, I'm paying all of that upload time and cost to get that object in. For us, if you have an application that you need this sort of design parameter, you actually can construct it in such a way that you can delete just or replace just certain chunks of an object. So again, because of that block concept, you can replace certain chunks of the block. We also have support for optimistic concurrency, right? So that's an interesting thing where you can do things without locking the object completely. You can say, hey, if something hasn't changed, let's go ahead and do a lock-free write or a checked read, if you will. We do support locks on objects too, so you can have a timed lock that expires if your code crashes or whatever, or you can have an infinite lock on a blob to make sure nobody else writes to it. So this is some of a very high level, some of the top level things that you should think about when you're thinking about blobs on our system. We do have a talk, as I said, last year's build that we did. It's on channel 9, so we did a little bit more double click into this. So I'll kind of leave blob storage aside a little bit and talk about big data and how blob storage integrates there. So let's think about what do we really mean by big data, and look at the use cases first. Of course, the core use case is I need a place to do my analytics, I need a place to do my machine learning, and I need that. But usually, big data has all of these other use cases around it too. You have ingest and ETL, so you're bringing the data in, whether it's coming from devices, your company, or somewhere else. You may be streaming the data in if it's an IoT type scenario and you're streaming data in rather than writing objects or transforming them. And you run your analytics jobs, and then you may need to publish data aggregates that you then need to present back to you within your company, back to your users, et cetera. So if you look at this as a continuum, Azure offers a set of services on each of these use cases. So let's start with the first one. With ingest and ETL, we have event sources that you can publish to, like App Insights, Azure Monitor, Log Analytics, and the like. And you can transform and load and save those things with the Data Factory service that really allows you to move data from one type of data to another type of data with broad support for many, many different kinds of data formats. On the streaming side, we have event hubs for general purpose streaming data. And we have IoT hubs specifically for IoT streaming and IoT two-way control back to the device as well. On the analytics side, of course, we have a bunch of different services, starting with things like functions for serverless computing, moving to things like batch. If you have a large high-performance computing jobs, you can go run VMs and have your jobs run in VMs with an orchestrator coordinator. We have stream analytics to take streaming data and do work with it. And we have data lake analytics to go run analytics or Hadoop jobs and the like. And of course, we have our machine learning service to go train models and publish them and then run those models against your data sets. On the aggregation side, we have a lot of data services, of course. I'm just showing data warehouse as one example of place where you might want to publish aggregates. And lastly, of course, you want to visualize that data. You may do that in Power BI. You may build your own, a single-page app and then publish data on, through a CDN. You may use our managed search service, and there's some other services there also. But another big piece here we have as part of our commitment to openness is how do we support the open source Hadoop big data ecosystem? And the service we have around that is called Azure HD Insight. It's our managed Hadoop as a cluster, Hadoop as a service cluster that you can deploy and then have access to all the Hadoop services within that cluster. So whether you're running a Spark job, you're running Storm, you're running MapReduce jobs, you're storing your data in Hive, you're using one of those interactive notebooks, you're using Kafka for streaming, you can actually go build all of that on top of HD Insight. Now, the common piece that ties every one of these services together is actually blob storage, because every single one of these services needs to go fetch the data from somewhere, and if it operates on the data and outputs data, it needs to actually store that data somewhere. So under the covers, you'll look, if you can go look for the documentation for every service, there's a blob storage connection, and how do you configure your storage accounts? How do you get data in and out of these services? So that's sort of the unifying layer when you think about this. So that's something to keep in mind, is even if you're thinking about these higher layer services, it's helpful to know what we're doing underneath the covers to enable them. So let's have an example, a couple of examples of real customers who are doing stuff with our service. An example of this with geospatial data is a company called Cyclomedia that has petabytes of high-resolution, high-scale imagery, both in Europe and the US, where they drive cars around kind of like street view imagery, but much higher resolution. And they're storing that raw data in Azure. They're transforming it, and they're building a service for smart governments and things like that around this geospatial data. In the IoT space, we have ThyssenKrupp, who has all of their newer elevators equipped with IoT sensors and pumping data into Azure IoT Suite, and then pulling that data out and doing post-process jobs, machine learning, and the like. In fact, I noticed on the way up, the escalators we've been riding up and down for the last 3 days are ThyssenKrupp escalators. So it's interesting to see how much they're buried everywhere once you start noticing them. They apparently have 1 million+ elevators in 150 countries around the world. On the genomic side, this is really exciting as well, because we're getting to the point where in a few years, first thing that happens if you visit a hospital or a doctor is we're going to have our genome sequenced. The technology is getting there. It's a huge data and computation problem. We're collaborating and working with Stanford Medicine through an ISV called DNA Nexus. They've adopted Azure as their place for clinical genome sequence data. So if you go and check into the Stanford Medical Center, they will sequence your genome, and that data ends up on Azure and processed on Azure. So there's petabytes of data, millions of core hours that are running to make that academic research hospital understand our genomics data better. So this is examples of real customers. So let's take a look at some things that you can do in terms of a demo and what we can show you there. So I'd like to ask Michael to come up and do the demo.
Right, so Vamshi has been talking about a bunch of the storage integrations. And so let's take a deeper dive into some of those integrations in the context of a larger data set. So in this case, we chose for our data set clinical trials, which are publicly accessible on clinicaltrials.gov. There are more than 200,000 trials, which represent studies that were done on human participants around the world. And like I said, they're available publicly on clinicaltrials.gov. So the first thing that we did is we uploaded these clinical trials to a storage account. So let's click here. And let's take a look at one of those files. So we'll notice here that we're hosting this at an Azure Blob, right? We got blob.core.windows.net. And so that's nice, but to display these to our users, we may want to host these at a custom domain. So we'll notice here that now we have this custom domain, storagedemos.com. And Azure Storage has supported custom domains to access your blobs for a long time now. But a frequent ask that we hear is to also have SSL support for those custom domains. Now you can do that. So if you notice, we'll refresh the page here. And we will notice that we have HTTPS on that custom domain. And if we click on that request, we'll also notice that that's just a block blob. So how do we do that? So the first thing that we did is we made sure that our container granted anonymous read access to users. So we can come in the container here, look at the access policy, and make sure that anonymous users can access the blobs in our container. The next thing we did is we set up an Azure CDN front end on top of our storage account. So if we come back into the storage account here, we'll notice that right from the storage account, there's Add Azure CDN. So we can click on Add Azure CDN, and there's just a couple simple parameters that you need to input to easily put that CDN front end on top of your storage account. So I've already created one. Let's click on it. Very quickly, we can just add a custom domain, and then once you have that custom domain, you can click one-click HTTPS enablement. So you'll get an email to verify that you are the owner of that custom domain, and then HTTPS on your custom domain to access blob storage. So that portal integration went live just last month, and the feature has been live since February. So the first thing I showed you here was custom domain with SSL support via CDN, and like I said, G8 in February of 2017. So let's come back to our data one more time. And this is a great way to display one of the files. But remember, we have over 200,000 clinical trials here. So it makes sense that we want to set up maybe a way for our users to come and search this data. So we could use Elasticsearch or Solr. But instead, we've decided to take advantage of Azure Search. And Azure Search is a search as a service offering on Azure that takes care of that infrastructure management for you. So once again, we can go directly to our storage account, and we can scroll back. Scroll back here, and right underneath Azure CDN, we see Add Azure Search. So this portal integration went live just last week. So we can click on Add Azure Search. The first thing that we need to do is we need to pick our service. So I've already set up a service. We'll click on that one. The next thing we need to do is connect to our data. So we have Azure Blob Storage selected. We'll come and select the storage account that I have and the correct container. And then we can input the virtual directory path where the files reside that we want to index as well. So we have clinical trials. I'll click OK. So it'll sample our data, and it's going to run for a couple seconds here. And the next thing that we're going to do is we're going to actually go and define an index on that data. So we'll see that we have a couple of fields, but the one I want to call out here is content. So content just represents the text of our clinical trials. So we want to make sure it's retrievable, which means we'll get it back in our searches. And we want to make sure that it's searchable, so we can actually go and search this content. And we'll click OK. And the last step here of setting up the search index is just setting up an indexer, which is a job that actually comes around and indexes your data. And you can just set that up on whatever schedule you want to. So I've already set up this search index. So let's go. And the nice thing about Azure Search is that we've also provided a thin UI on top of the Azure Search APIs that'll enable you to kind of quickly test from the portal your search index. So we'll come into the Search Explorer here, and we'll make sure we have the right index, clinical trials full text index, and we'll search for, say, myopia. And you'll notice very quickly we get back all these documents that have the word myopia in it. So that's great. So we have a full text search here. So once again, I showed you the custom domain with SSL support via CDN, and then the Azure Search Indexing of blobs, which GA'd, the blob integration GA'd in November of 2016, full text search. So I want to return to our data one more time. And we'll notice that though these are text files, they're actually structured to these files, right? They have fields, summary, description, et cetera. Azure Search handles JSON objects very well and can take advantage of the JSON structure. So let's try to convert these files to JSON. To do that, we spun up an Azure HD Insight cluster. So Azure HD Insight cluster, like Vamshi was saying, is Azure's managed ecosystem to enable you to run open source Hadoop analytics workloads in the Azure cloud. So we'll notice that we have a couple of head nodes, 13 worker nodes. But what I do want to call out here is that we've connected our storage account directly to this HD Insight cluster. So this HD Insight cluster natively supports blob storage. We can read to and or read from and write to blob storage directly from this HD Insight cluster. So let's run some code. So to do that, we'll go in the cluster dashboard, open up a Jupyter notebook, where Jupyter is just a web application that enables you to write live code. And so we'll click on the notebook that I've made. And we'll notice that this is just some text parsing code to convert our files to JSON. But what I want to call out here is this WASBS string. That represents the native connection to Azure Blob Storage. We are reading in from Azure Blob Storage and then writing out directly to Azure Blob Storage. So we can run this, and this is just on a subset of the trials. And when that little dot goes hollow, we'll know it's done. You notice we're writing out to clinical trials JSON live. So if we come back to our storage account now, come into the right container, and we'll notice that now we have this virtual directory clinical trials JSON live. So we have a couple of files here. Each one of these is one of the files that a partition outputted. Each represents a JSON array. So let's take a look at one of those files. So you notice here that we have much more structured data now, right? We have the key value pairs. We have JSON. So now let's go and set up an Azure Search Index on this JSON. So to do that, I'm going to show you how to do that programmatically now. So to do that, I'm using Postman to submit REST requests. So the first thing, once again, is we create our data source. So we point to our storage account. We create the index, so we now have more fields, and we define some properties on those fields. When we create the index, we get back the JSON schema of our index, which we'll need in a second. And then we create the indexer, which is, once again, that job that comes around and actually indexes your data. So to show you this search experience, we've also created an app, the Azure Search Generator, which enables you to input that JSON schema that you just got back on creating the index, the query key, and then the name of your search service, and you quickly generate an HTML file. So we did that, and we're hosting that HTML file at our storage account. So once again, it's at our custom domain name, and we'll come here and take a look. So we see we have over 200,000 documents, and now we have a much richer search experience. So we'll once again search for myopia. We'll notice there are 222 documents. But now we can do cool things like we can pivot on the phase. So if we pivot on only those trials that are in phase 4, we can see that there are 22 of them. And phase 4 is just trials that the drug is already in sales, and we're just doing further validation. So we'll see we have 22 of those trials. That's great. The last thing, well, before I move on, I want to just kind of recap here. So we showed the Hadoop ecosystem via Azure HT Insight to transform those files into JSON files. The last thing I want to show you about Azure Search is that we can use Azure Search to only index the metadata of our blobs. So sometimes we have very large binary files, like media, for example. In our case, we uploaded a couple of genome sequences. So what I want to call out here is the size of these genome sequences. That one's 383 gigabytes. And that's just binary data. We don't want to crack that open. We just want to index the metadata. Azure Search can do that. The other thing I want to call out here is the size of the file. So as of December of 2016, Azure Block Blobs now support 5 terabyte file sizes. So let's go and really quickly show you on the search index what that looks like. So we'll go in the genome sequences index, which I already set up, and we'll just return all the files here. So we can see that we have some custom metadata, for example, the patient ID, and then we also have the system properties that storage defines, for example, the storage size. So we only index that metadata with Azure Search. So once again, these are the things I showed you: the custom domain with SSL support via CDN, the Azure Search indexing of blobs, full text search, the rich JSON search support, blob metadata only indexing for binary data, and then finally the Hadoop ecosystem via Azure HT Insight.
Great. Thank you, Michael. So as you can see, this is some of the improvements we've been making in terms of our integration and how you can tie all of these services together. So that's roughly what the services we showed you, as well as the use cases we exercised. Now, one of the things that we want to then focus the talk on is what inside Blob Storage enables that. And to do that, just to give you a taxonomy, we split it into these pillars. Right? Open interoperable, manageable cost efficiency, scale and performance, of course, you're talking big data, security for that data and compliance, and of course, the base durability and availability. So let's take a look through some of these pillars. Let's talk now about what we have as well as what we're building to enhance Blob Storage for big data along these pillars. So we'll start with open interoperable. One big part of that is having the right set of SDK and tools for you. For developers, we have a bunch of open source client libraries ranging from .NET, Java, C++, Node.js, and more. All of them are on GitHub. And we also have good mobile platform support for both Android and iOS. We also added a data movement library for a high-scale, high-speed data ingestion and egress. So you can just take that library and use it rather than doing all the threading work and the correct sequencing of parallel uploads and downloads. We've built all of that into another open source library that you can take and use as a binary or adapt the code for your needs. It is core CLR based, so you can use it on multi-platform. And on the tool side, we have Storage PowerShell, of course. But we also have our newly written CLI 2.0 based on our Python client library. So again, multi-platform, Linux friendly. We have AZ Copy, which is like RoboCopy for Azure Storage. And we have a user experience thing called Storage Explorer. If you go to storageexplorer.com, you can get a nice little free tool that runs on Linux, Mac, and Windows to go as you're developing against storage accounts. A lot of this work as well has been done within the last year in terms of improvements in what we can do. The biggest thing that we've done is move all this stuff from .NET to Core CLR to make it multi-platform. And then doing that CLI 2.0 on Python gives us a lot more flexibility. The mobile web support, we've done a lot of work there, especially around Xamarin support, having a JavaScript library, and having a Node.js with support for TypeScript, and that's GA as well. Some other improvements here too. Now, one of the asks we get very frequently from our customers who use Blob Storage today is, I love AZ Copy, I use it on Windows, when are you going to have it for my Linux installs? We're happy to announce that we have AZ Copy on Linux available as a preview today. We had this go live a couple of days ago. So you can go to that link, download it. We rewrote this command line interface, of course, so it's Linux friendly. You can use it when you're Linux in your bash scripts or other ways. And so this is available as a preview. We'll love to get some feedback on it, and we'll GA it soon as well. On the manageability and cost efficiency side, we've also been making improvements. So let's start with the thing that's very near and dear to many developers' hearts, which is how do I monitor my stuff? I'm doing all this work in storage. What do my metrics and logs look like so I can do self-service debugging? We've had metrics and logs for a long time. We are one of the oldest services in Azure. We launched back in 2008 as a preview. We've had metrics and logs for many of those years, but now we have this thing called Azure Monitor that brings together all the monitoring across all the different services into one common schema, and we're starting to integrate with that. The benefits you get from that is, one, unified APIs regardless of which service you use in Azure. Easy to set up charts and alerts based on metrics because they follow a common schema. You can, of course, archive data from many analytic services and collect them from many storage accounts into a single storage account. And then you can even stream that analytics data into our streaming services to do more with it. So all of that integration, we will take our existing log and metrics formats and move it to that. We've started a limited preview of that, and we will be looking to ship that later this year. So if you've looked at Azure Monitor, you like what you see, and you're asking, hey, when is storage going to get there? It'll get there this year. You, of course, have what we have today to go use right away. Another common ask we get in terms of manageability is data protection. Particularly, how do I deal with oops deletes or code bugs which delete my data? And so far, we've never had a way of dealing with that. If you delete your blob, you've deleted your blob. We're happy to announce that we're working on a feature called the recycle bin, creative name, I know, recovery from accidental deletions and overwrites. So this is something that you can configure. You can set up the number of days you want to retain your data after deletion and the number of versions if you're overwriting the same blob over and over again. And you can, of course, turn it off. If you absolutely need hard delete, you can turn it off. It's a blob level thing, so you can go in, you can list your blobs, list deleted blobs and undelete blobs. So it works really well from that perspective. We expect to GA that in the fall. And what we're doing around this is to also then extend this to other forms of data protection. We're going to build this into full-blown object versioning for your applications. That's coming next. We'll also do things like supporting immutable blob storage and worm support for places where you need that, especially for regulatory reasons. Another aspect of cost efficiency, from moving from manageability to cost efficiency, is cool storage. We launched this last April, right around build last year. And what it gives you is two blob tiers, hot and cool. We talked a little bit about this. It gives you the ability to trade off, do I have hot data that I need transaction to be cheap on, or do I have lots of bulk data that I don't expect to access very much? The nice thing is the API is 100% identical. The latency is very similar. You have all the same durability options and whatnot. It's the prices that change, so you can map and be efficient there. So today, that's an account level switch. Your blob storage account can be hot or cool, right? So that works today. You can go create a blob storage account. You can use this today. Where we're going next with that is building on that to build a notion of tiered storage. We're going to move from an account level tier to an object level tier. So you'll be able to mix your hot and cool data in the same blob storage account rather than having a hot account and a cool account having to manage that. You can just call an API and have stuff move over. And all of those tiers of blobs can coexist in a storage account. The other thing we're very pleased to announce is we're adding a third layer called the archive blobs layer, which is going to be an offline storage layer, right? So the idea here is it's offline storage for long-term retention of data. Unlike hot and cool, which are instantaneous access, archive will be hours to first byte. But the neat thing here is we'll keep that consistency among APIs and storage tiers. So you will have an API that you can write directly to archive storage, but it is the standard Azure Storage API. You'll be able to hydrate data from archive into hot or cool. So you'll be able to mix that offline data with your online data. All the metadata for your offline data will be queryable. So you'll be able to know that your blob storage account contains a mix of hot, cool, and cold data. The preview for this is coming soon. We'd love to have you folks participate. If that's something that's interesting to you, please send us email. There's a small typo here, so I apologize for that. It's actually Azure Storage Feedback. So it's AZURE Storage Feedback at Microsoft.com. We'd be happy to accommodate you in that preview. And we'll, of course, go to public preview fairly soon as well. The way this ends up working, again, if you look at it from a portal perspective, is you have this access tier now on every single object. You also can change the object tier at any time. And if you have an archive tier and you're hydrating it, because it takes hours to hydrate it, you'll have this archive status that tells you what's the status of that blob. Now, you will be able to set the API. You will be able to have get APIs return things, right? And in the future here, we're going to add automated lifecycle management and really give you the ability to do this with just policy. Well, starting with APIs, we're going to move to the automated way of doing things. So this is a quick wrap-up of what we're doing in terms of open and interoperable and manageability and cost efficiency. And I'm going to turn it over to my colleague, Chris, who's going to do another demo showing integration here, another form of integration with our big data services. Chris? Thank you.
I'll do it. I'll change it. OK, so thank you. So let's take a pause and let's pop up again and show another demo. Before we showed one where we did some ETL and some analytics. I want to show another scenario that's more arranged around streaming of your data. So there's a lot of scenarios in big data where we have continuous streams of events, maybe IoT, maybe telemetry from your applications or your sites. And often people do real-time analytics on that data. They'll connect it to something like Stream Insight, and they'll be able to react as events happen in their flow. And so Event Hubs is a service from Microsoft that's really aimed at this space. It's about ingesting at super high scale these events as they're coming in, and then connecting them to real-time analytics scenarios. But it also provides the ability to store that stream of data for long-term use. And what this really enables is an important part of big data. Because the economics of storage have changed, so it can become much more less expensive to store stuff long-term, and the scale has changed, we've enabled a scenario where you can just keep all your data. And you may not know all the questions you want to ask about it now, but when you figure those questions out, you can go back later and get to the data. And so Event Hub Archives provides that. I just want to show you real quickly. Here's what it looks like to send data to Event Hubs. They have APIs for .NET and Java, and it's an open AMQP interface. But it's very simple. You just send a byte array of data, add some metadata if you like, and send it. Event Hubs gives you, the constant stream of data, but it also lets you configure that archive of data to a storage account. So here's an example of that, where we've configured this Event Hub that's receiving data. In our case, this data is the super high volume of interest in medical terms, in medical trials that we saw the search experience before. Let's say we're taking that telemetry and we're streaming it to Event Hubs. And you can see here that we're archiving that off every 5 minutes into our storage account. You can see that same storage account we saw before, the build demo and the data container. And we're going to create these files, based on that time as it's streamed out. So if we go look at that data, you can see here's that container, and we have a search logs folder. And you can see we have this set of files. These are Avro files. This is an open Apache file format that's essentially a binary JSON format, a self-describing binary JSON format. So it's used by a lot of these open source tools. So now we've got this Event Hub, and we're constantly streaming data, and we're saving it to storage. And let's say we discover there's something we want to dig further into the history of our data on. Now you can, in real time, spin up, for instance, an HD Insight cluster like the one we saw before, and use that compute cycles to examine your data, and then put it back away. So you don't have to keep a cluster up all the time that you're storing the data. You can decouple the storage, store the data very efficiently using the tiering we talked about before. And then when you want to analyze it, you can spin up the compute, attach it to it, and use it. And so that's what we've done here. We've attached that HD Insight cluster to that same storage account. And now we can interact with it. You saw how we connected it before. I want to use the feature we saw at the keynote, which is a cool feature. We'll just connect to the console on this HDI cluster. So let's do that here. So we'll just SSH into the console of the cluster. And now we're in the head node of the cluster. And so this is how you can see those files directly on the cluster. So we talked about how we map them to the system. So this is using the Hadoop file system commands. And now the Hadoop cluster can just see those files that are stored in my storage account, and it sees there's those same Avro files. So the scenario we have here is that we've been real-time monitoring our data, and we noticed kind of a spike, a new search term last month that was interesting, and then it went away, and we wanted to know why that happened. And so we dispatched our data scientists to go look a little deeper into what was happening. And so we're going to use the same idea of an HDI cluster, and we'll use Spark. And Spark has this idea of Spark SQL, where you can essentially run SQL queries against your data, and you can attach directly to files and treat them like tables. So that's what we've done here. We've loaded this Avro package, so we know how to interpret those Avro formatted files, and we've mounted that whole directory of files as a table. So you can see we've created a temporary table called search history. And we've pointed to that folder full of files. And now it's just like any other table, and we can query it. So you can see that we have, we can describe the table. So these are the fields that it discovered out of that self-describing Avro file. It includes the various parts of the event that we logged. And the interesting part for us is in this body. Of course, we can put anything into the binary body. In our case, we put string data in it. And so you can see this is the binary version of it. But if we use SQL to cast it to a string, we can see the comma-separated event search logs that we've done here, when the search happened and what the search term was. And then we can just use simple SQL to parse those things apart, and we can get to the individual fields. In our case, we have about 1.6 billion records, so a whole lot of data we've accumulated over time about this search history. And so we'll show you this is kind of what we saw at the end of the year. We saw kind of a spike in traffic about this particular topic, indigestion. So we're searching for, this is just showing you the end of the year history on indigestion. And so we kind of got a spike, and then it went away, and we're not sure exactly why that was. And so we wanted to do a little more. Actually, let me show you the query here. So what we did is we dug a little deeper. And we said, well, let me look at indigestion over the last 3 years. And let me just look in North America. And you'll see there's a bit of a pattern here. Right about March of every year in North America, we seem to have a big spike of indigestion in our case. So I don't know if you have any basketball fans, but I think maybe that's the root of the situation here. People are eating a lot of fatty food, and they're stressed about their spike. So this is an example of a question we didn't know to ask, taking advantage of this long history of data we can keep economically, and then be able to gain insight from it using these tools. All right, so let's go back. So here's what we saw. We saw ingesting data with event hubs, using Spark to interactively query directly against that storage account with a cluster that we brought up on demand. And then in this case, we used a Jupyter notebook to query that stuff interactively. We could have done the same pattern with Kafka as the event ingestion system, which can also write to storage. We could have used Data Lake Analytics as the query engine. We could have used Power BI on top of one of these tools as a way to visualize this data. So lots of choices about how you can leverage the data in storage. All right, so we're going to keep moving. We're running behind. So a couple of times now we've seen this idea of a storage account connected to a Hadoop cluster. I wanted to just dig a little deeper on that real briefly. This is done because the architecture of Hadoop takes the file access that happens from these application frameworks or even from the shell commands that you saw me run against an abstraction layer of file system API specification. And the original distributed HDFS that runs on all the compute nodes uses this format. But you can also plug into this drivers for other file systems. So in our case, we've written what we call the WASB driver, which is a driver against Azure Storage blobs that are stored remotely. And this ships as part of the Apache Hadoop framework. There's other services that plug in here as well. We're continuing to improve this driver so we get more and better compatibility and performance, including things like semantics around the way HDFS flush behaves, people being able to say, I want to make sure that data that I'm working on is actually persisted to disk before I continue. And we're supporting, as new features evolve in the service and new protocol versions, we continue to update this driver so it takes advantage of those. We'll go pretty quickly through durability. Vamshi covered a lot of this. We talked about strong consistency. We store 3 replicas, as he said, and then in the background we do erasure coding. I just want to talk about durability in general. It seems like a really boring topic, but when you're storing a whole lot of data, finding a way to manage the fact that disks can fail and servers can fail is a pretty complicated job to do on your own. And this is one of the real benefits Azure Storage as a Service provides. Is we have huge levels of automation and software that takes care of these things for you. Data integrity is another example. We have background processes that are constantly scrubbing your data. So if something goes wrong and a file gets corrupted, we can detect that right away, throw the corrupted copy away, and regenerate it from other copies. We talked about disaster recovery services. We also offer financially backed SLAs, 99.9% availability SLA. And if you use that geo-redundant service and you run your read queries against your copy of your data, you can have 4 nines SLA for reads. Let's talk a little bit about security. More and more customers are using these big data technologies against sensitive data, or they're doing it in industries where they are bound by regulatory or compliance obligations. And one of the most common things they tell us is we have to be able to encrypt this data to meet the letter of the law in our business, and we don't really have a way around it. And so we've introduced this idea of storage service encryption, so we can make that very easy for you to meet your compliance obligations. And so this is essentially a checkbox you can do on your Blob service account. And say, I need to make sure that everything I write to disk is encrypted so I can meet my compliance needs. And this really is designed to protect against the idea of a physical disk walking out of the data center. When you send your data to and from the storage service, it doesn't have to be encrypted. It just looks like regular data. But when we put it on disk, we encrypt it, and we make sure that if anybody could ever get out of that data center with that disk, it doesn't matter. They can't get to the data. Of course, we have lots of layers of physical security to prevent that from happening in process. But this is important for people's compliance needs. So today you can encrypt that data using a Microsoft managed key for blobs. We just announced this week that, and we also have our file share service that Vamshi showed earlier. This is available for files as well. And then Microsoft has sort of a company-wide initiative to essentially say any data we store anywhere, we need to make sure is encrypted. And so we'll be moving to, in the second half of this year, essentially every one of the storage accounts will have this enabled. You won't even have an option. You won't turn it off. It's just always protected. So so we're just going to move to that, and then we'll begin the process of encrypting all the existing data. So the data is just secure, and you don't have to worry about it anymore. Some customers have higher levels of requirements around how they encrypt their data, and they need to be able to manage the keys and manage the rotation policies to specific levels. And so we're introducing the idea that you can do this server's level encryption using a customer managed key. So a customer can provision a set of keys in a key vault, attach their storage account to that key vault, and then their data will be encrypted with those keys, and they can manage it. Of course, encryption in transit. This is HTTPS. We've offered HTTPS protocol support forever. We've also offered the ability to issue SAS tokens. So if you want to give somebody access to your data, you can say their access is only over HTTPS. But customers still told us, I need to be able to guarantee that no matter how people access the storage account, it's always over a secure protocol. And so we've added that. We're adding that control option, essentially a setting on a storage account where you can say only allow HTTPS traffic. And so through this, you'll be able to enable this on a storage account, but you'll also be able to use things like ARM policies or Azure Security Center to enforce and monitor your compliance in this case, which is really important, again, for these compliance obligations. And this is coming in the second half of this year. We also hear from customers quite often that a single layer of security, authorization, is not sufficient for their needs. And their policies are that they have to have layers of security. So if one control fails, that they have another one that's going to protect them. And so one of the common patterns they ask for is the ability to control what networks can access their storage account. And so this protects from cases, for instance, where your storage account key could somehow be disclosed or given out by a rogue admin or something. And you want to make sure that you can't go on the internet with that key and just download my data, for instance. And so we're building a feature called VNet Access, Azure Network Access Control for storage, where you can lock down a storage account to specific networks, whether that's an Azure VNet or a specific internet IP address range. And this really gives you the control you need to make sure that you can have those layers of security. And this is coming in a preview in the second half of this year. We already have some customers who are testing it for us, and we expect very soon to have a public preview for this. A couple of more things. Apache Ranger is a framework in the Hadoop ecosystem that all the applications can use to provide a common place for authorization policies. And today you can use that to control all the standard Apache services, including things like column-level encryption in table-oriented stores like HBase. We're extending that to allow you to use Ranger to control access to individual blobs or folders inside of WASB, in that WASB driver. And so that looks like this. You can point to a specific relative path in a specific storage account or container, and you can say only this user can have this specific access. So it gives you that sort of low-level granular access control in the standard Ranger framework. And this is coming as part of the Secure HD Insight preview in July. So look for that. And finally, more generally in the storage account, we have had lots of feedback from customers that they'd like to move beyond single storage account keys or SAS tokens derived from those to something more based on the identity of the caller, whether that's a user or an application. Today, you can do that against our control plane. So when you do management operations, the ARM framework allows you to use OAuth and Azure Active Directory identities and to provide granular role-based permissions to what operations different identities can perform. We're extending that framework to the data plane for the blob service so that you can, on the operations on blobs and containers, you can use that same identity system and authorization system. So we're going to integrate with the role-based authorization framework and extend it to include operations on containers, blobs, et cetera. You'll be able to assign specific permissions down to at a container scope. So you can say this identity can access these kind of operations on blobs in this container. In the future, we know we want to go even further down to the level of an individual object, but this is the first step for us. And this is coming in a preview in the second half of this year. All right, we're so close. Before we finish, I just want to touch on perf and scale. I know there's a lot of exciting work here. Specifically for people who are doing their own VMs to do these big data scenarios, today we have sort of limits in how big a disk you can attach to a VM. And in some very extreme scenarios, this can be a bottleneck for some people. Today you can have up to a terabyte-sized disks. In June, we're introducing larger disks, so up to 4 terabyte-sized disks, of which you can mount many in a particular VM and have up to 256 terabytes on a particular VM. With a high scale of IOPS and throughput. And we're also introducing some smaller size disks as well if your scenario really calls for a smaller disk size. And this is in preview now in West Central. And you can use PowerShell or CLI to use it. And it's coming in the portal soon. And in June, again, it'll be available generally. The next one we talked a little bit about. For individual blobs, today, again, we can, in the past, actually, you can only have 200 gig blobs. Michael talked about this change going up to 5 terabyte blobs. This is important in some scenarios in oil and gas and other places where we have very large files that we need to operate on. And we're also doing equivalent throughput improvements, so you can write to these very large blobs in parallel with the kind of throughput you need. And we're also doing work for small block blobs. So if you have a workload that operates on lots of very small blobs and lots of reads and writes, we're doing work to improve the read latency of those blobs and give you consistent low latency access to small blobs. Finally, the overall scalability of a storage account. When we designed these, as Vamshi said a long time ago, we put limits that felt like really huge numbers. They felt like almost infinite. We said, what if you could put 500 terabytes in a single storage account? And it's amazing how the world changes. Now people say 500 terabytes, not that much. I need to do a lot more. And so we're doing work to allow us to have much more in a single storage account, to remove those barriers. And we're starting with a preview this summer that will allow up to 5 petabytes of data in an individual storage account. and to also raise the throughput and transaction rates that go along with that. This is really just a first step for us. We're going to do a preview. We're going to make sure it works for people. We're going to try to push these limits to a place where they're essentially invisible to people. But we're really excited about this. We want to get people out of the business of having to maintain multiple storage accounts that they shard across. We don't think you should have to deal with that complexity. We're also doing some specific work with the HD Insight team so that their sort of heavy, spiky workloads that will hit a storage account very hard with a big scan across all their data, we can pre-optimize for them. We can scale out where their data is served across a storage cluster and be able to respond immediately without delays while we scale. All right, we made it. I'll leave it to Vamsi to wrap this up.
Thank you, Chris. And so just to wrap up, hopefully we've given you sort of a taste of what our services are that help you with all of your big data use cases and how blob storage integrates with those use cases. We've also given you sort of a sense of our investment here. This is an incredibly important scenario to us. We have a lot of good functionality here, but we also know that we are continuing to invest in this, and we have a lot of good, exciting stuff coming later this year that will enable those scenarios along those pillars, particularly in security, scale, and performance. You'll really be able to rely on blob storage as your unstructured data source for all of your big data needs. So thank you for having attended this talk. Please do fill out surveys. And we're here for questions. Our booth is right down there. So happy to stick around as long as you want to answer questions all the way through the end of the conference. Thank you so much.